Today we will discuss about the nature of roots of a quadratic equation. Now, as you are aware, a quadratic equation is like this, a equation of degree 2, where the coefficients a, b, c are real and a is not equal to 0. When we want to solve this quadratic equation, we have a formula which gives us the roots of this equation. Now, in this formula, we are going to get two roots. In this formula, we are going to get two roots based upon the values of b square minus 4ax, 4ac. We will actually be able to see that if it is a positive quantity, this square root will become a real number, else it will become an imaginary number. So, this term b square minus 4ac is very significant as far as roots of this quadratic equation are concerned, nature of roots of this quadratic equation are concerned. We call this expression as discriminant and denoted by d. So, whenever we have a quadratic equation, we will be able to calculate this number d using this formula b square minus 4ac. And for discussing the kind of roots, we will write down the following conditions. The first thing is, if d is greater than equal to 0, that means b square minus 4ac is greater than equal to 0, then both the roots are real, out of which we can separate two cases. One, if d is equal to 0, then we get equal real roots, and if d is greater than 0, then we get distinct real roots. Distinct means unequal. Now, how do you see this? In the given equation, when you calculate using this formula minus b plus minus b square minus 4ac upon 2a, you will use a plus minus sign here. Once plus is used and minus is used, if this number is 0, under root d b square minus 4ac, because of d being equal to 0, then using plus minus will not create different roots. When the number is non-zero, under root b square minus 4ac having d greater than 0, then the roots will be calculated with plus minus sign and they will have two different results. Okay. Now, the second criteria would be based upon a negative discriminant. Now, in the second case, if d is less than 0, then both roots are imaginary and they occur in conjugate pair. Now, we can see that when d is negative, when you calculate this under root b square minus 4ac upon 2a, this expression being negative, you will be able to see that under root of a negative quantity can only be covered with the help of iota. You understand, minus 1 is iota. So, whenever we have an example like this, x square minus x plus 1 equal to 0, if we find out d, it gives us b square minus 4ac, which is equal to minus 3, it is negative. In that case, when we calculate the root for this equation, we get it as minus of plus 1 plus minus under root minus 3 upon 2. Now here, if you simplify with the help of iota, you will get it as this upon 2 separated like this. Now the roots which you get here, minus 1 by 2 plus minus root 3 by 2 iota, these are two imaginary roots. And what is meant by conjugate pair? By conjugate pair we mean that if a plus iota b is a root, then a minus iota b also is also a root. So what is meant by conjugate pair? Then if the coefficients of the quadratic equation are real, then roots will come in conjugate pair, where if p plus iota q is a root, then p minus iota q will also be a root of the quadratic equation. Okay? Where we have assumed that p and q are real numbers. We have assumed then p and q are real numbers. Alright. Now we will take up certain problems on this concept. We will take up certain problems on this concept. Write down a equation, write down a question. For what values of m, the equation 1 plus m x square minus 2 1 plus 3m plus 1 plus 8m equal to 0 has equal roots? Now, as we had seen that in case of equal roots, we apply the concept of d equal to 0. Now, in this quadratic equation, let us find out d and equate it to 0. We will solve that equation to get the values of m. So, when I use b square minus 4ac equal to 0, I get 4 times 1 plus 3m whole square minus 4 1 plus m times 1 plus 8m equal to 0. I can drop 4 from here and then I simplify. I get 9m square plus 6m plus 1 minus 1 plus 9m plus 8m square equal to 0, whereby after simplification I get m square minus 3m equal to 0. So, the values of m can be obtained as 0 and 3 by solving this quadratic equation. So, when we say that I use the value of m as 0 or 3 into the given equation, I will be expecting equal roots. And let me also make it very clear, when we get equal roots, we get them as real. Whenever we talk about equal roots, the roots are definitely found to be real. Now, let us go to the next question.